So before we go to the other subtopics of integration by parts, I would like us to do some couple of examples so that we can kind of get a clear understanding of what integration by parts is. So the first example that we want to consider is one to evaluate integral of, let me write here, evaluate the integral of x ln x dx. So by the time you finish evaluating this example, you will get to understand or get a clear picture of how sometimes you need to make your decisions on choosing your u and your dv. So because of that, we are going to make some trial and errors over here, so that when you get a question and then you are supposed to do something about it, you will know where to go and where to pick your things from. So having example like x ln of x dx, let's assume that this whole function, we are making this whole function to be 1. And in this case, we can say that our u equal to 1, and our u is equal to 1 because when we make this whole function as one function, it's 1 which is multiplying it, and we can say that our u equal to 1. And therefore, we can say our dv equal to x ln of x dx. As you can see, this is not going to help us because definitely we don't know the value of the integral of this one. That's why we even wanted to apply integration by parts. If we know the value of this, we should have done it straightforward here without even applying this. So you can directly see that this is not necessary. So if you do or make this assumption, it means that you are going way far. You are going wayward. So let's see something here. The second one that we want to consider is to make your u to be equal to x ln x, right? And then your dv equal to, let's say, 1 dx, which is the same as dv equal to dx. So in having this, you can find the differential of u, because per the formula integral of u dv, as I said, always write down your formula uv minus integral of v du. Per the formula, we need our du, and our du is equal to, when we integrate, now we need to apply product rule, and the product rule is to differentiate this, right? Differentiate this, multiply by this, and then differentiate this, multiply by this. So when we differentiate x, we are getting 1, and then 1 multiplied by ln x, right? Ln x. Plus, when we differentiate ln x, we are going to get 1 over x, then multiply by x. And don't forget that here is the u dx. So when we multiply both sides by x dx, we are going to get ln, because 1 times ln x is ln x, plus, now this will cancel this, so we have 1, and all, don't forget that here is u du, and we are multiplying both sides by dx. So we are going to get dx. So this is what we have for our du. and then our v. Now we have our dv equal to the integral of dx. And when we find the integral of both, we are going to get our v equal to x, because based on this formula, we need v from it, and this is how we are going to get our v. And from there, you need to do substitution into this formula. So we are going to say that we are going to have our x ln x, which is our u, and then our dv is what dx is equal to, now our u over here, where's our u? Our u is ln x ln x, and then our v here, it's x, minus the integral of the which is what? Our v here, and our v is x, and now our du, it's what? Ln x plus 1 dx. So from here, we need to further integrate this one, right? So when we want to further integrate this one, we are going to, or when we simplify this one, what we are going to get is integral of x ln x plus x, because I multiply x through to open the brackets, right? Or dx. This has become the same x function was given over here, and we need to do another integration on it. And when we don't choose the right values for our u and dv, we are going to go and repeat, of which we will come to repeated functions as well as one of the subtopics of integration by parts. We will come there. So looking at this one, we can see that this integral seems more complicated than this original one given, right? Because it's more or less x ln x plus additional x, which is more complicated than the one given over here. So in view of this, we will have to reconsider our values that, or our variables or our functions that we assign for dv and then our u. Therefore, we are supposed to go to the next trial. So now the next trial is that we have our function to be integral of x ln x dx. And since you have an integral of x ln x to dx, we need to make the right decision. And remember that I told you that mostly give u to the function of which when you differentiate, you'll be reducing the power. And when you look at this one, you can see that when you give u equal to x, we will be able to even reduce the power and then do whatever you want to do. But let's look at something here. When we give u equal to x and when we give dv equal to ln x, that also becomes a whole problem. And this is because we don't have the integral of ln x already, because we know that the differential of ln x is equal to 1 over x, but the integral of ln x is also another thing that we need to consider. It's a whole process on its own. So in this case, when we consider the assumptions that I made earlier on, that you need to give u to the function, that's the power should be decreasing. Sometimes you also run to a little bit of difficulty. So based on that, if you are using TI calculator, fine, you can use the TI calculator to punch integral of ln x, and then it will help you go straight away. But if you are using your hand and your head to do that, then reconsider assigning the values well, and therefore the final choice you would like to make is that when I choose u to be ln x, I'll be able to differentiate u easily without asking for any help anywhere. So that's emphasize the point that always choose u for function that can be easily differentiated, and choose v for function that can be easily dv for function that can be easily integrated. And therefore we can say that ln x is easy to differentiate, and then dv which is equal to x dx will be easy to integrate. And therefore this choice will help us come out with whatever we want to come out with. Now we have our u, but we don't have our du. So finding our du, differentiating our ln x, we are going to get 1 over x dx. And finding our v by integrating both sides, we are going to get x squared over 2, which is equal to v. Putting it into the formula, we are going to get integral of x ln x dx is equal to ln x, which is u multiplied by the v, it's x squared over 2, which is here, minus the integral of x squared over 2 multiplied by 1 over x dx. We can see that we can reduce the power over here, and therefore the resulting answer would be like ln x squared over 2 minus integral of x over 2 dx. And you can see that this one is easy to integrate. So in doing that, you are going to get your final answer to be x squared over 2 ln x minus x squared over 2 into bracket 1 plus 1, which is the power, because we need 1 plus 1 here, be 2. And then after that, you must be called, remember there is a 2 here. So at the end of the day, you are going to get x squared over 2 ln x minus x squared over 4, because 1 plus 1 is 2 times 2 is 4. Don't forget it's indefinite integral, therefore plus your c. You can check this by differentiating to see whether you are going to get your x ln x. So I'll leave that one to you for you to do to confirm your answer. So now we can say that the choice of your u and dv will allow you to evaluate this integral, and this is very crucial as you go on or as you learn in your calculus class. So now I hope that you understand, or you have gotten a clear understanding of how to choose your u and your dv, and how to go about solving some integration by parts question. Let's also look at another one over here. This is really quick, right? Let's look at this, which is evaluate integral of x square root of 5x plus 1 dx. As soon as someone sees this question, the person may start off, oh, I'll use substitution. So in this case, when you use substitution and you say that your u should be equal to 5x plus 1, at the end of the day, you will not be able to eliminate this one here. But it should have been possible if the x here should have been squared. And if it is squared, it means that after finding the u dx here and replacing it by dx as we did earlier in a simple u substitution, you will be able to eliminate this x to make your whole function simpler to solve. So in this case, since that x is not squared, I'm trying to delete from there. Since this x is not x squared, right, we can apply substitution over there. But there is another way that you can apply substitution, and that one, after doing this, you can decide to say, okay, 5x equal to u minus 1, and then you divide both sides by 5, and you're going to get x equal to u over 5 minus 1 over 5. And when you replace this one x here, square root of u dx here, right, you will be able to substitute this x value to replace this to make it one variable, which is u over 5 minus 1 over 5 multiplied by what? Square root of u. And then we will do our du here to make dx the subject to replace it for the dx, which is another way of solving this one using u substitution, and to become a whole lot of work. But to make your life easier, you can decide to use integration by parts. And let's check how we can use integration by parts to evaluate this.